Jai Hind everyone. So welcome back to our chemistry class. So in last day what we have seen that we have seen about that importance of chemistry, and also we can say that the application of chemistry we have learned. So let's start our today's topic that okay, this is the second class, the classification of matter. In last day, I think in the last day, a few concept about the matter we have told, and we are also telling that we are recapitulating our the previous study, that classification of matter, what is the class of matter and what are the properties of matter. So today we'll talk about that, what are the classification of matter. In your class 9 you have read about the classification of matter. So here I am just giving a chart so that you can just rememorize again, regain that topic, that okay, these were present that time. Okay, now if I talk about that, matter generally classified as a pure substance and mixtures. So when you talk about the pure substance, the identity of the element should be present there. Okay, so pure substance also classified as the element and the compound. If I talk about the element is a independently present. Okay, that and the compound, when the two or three elements mix in a fixed proportion, that time it is forming a compound. If I am giving example, then element, what are the example of element? If I talk about that, okay, sodium is the element. Sodium, I am just writing the formula of sodium is the element. Whereas if I talk about the compound, then we can say carbon dioxide is a compound. Carbon dioxide is a compound. Now these element and compound also can be classified. If I talk about the element generally classified as a metal, non-metal and metalloid. We have read in our previous classes. If I talk about the compound is also classified as an inorganic compound and organic compound. So two part is there. If I talk about the element here, this element has a three part, that metal, non-metal and metalloid. Similarly, if I talk about the compound has a two part, inorganic compound and organic compound. Now we are back to the homogeneous and heterogeneous mixture means when two or more substances are mixed in any ratio, then it is called mixture. Homogeneous means they are thoroughly mixed, they are mixed thoroughly. Okay, and heterogeneous means obviously the boundary should be there, and that are the example. If I talk about the example, then the water and sugar solution is generally known as homogeneous solution. When I talk about the heterogeneous solution, then it is a sand water solution, it is generally called that heterogeneous mixture. Now suppose I am asking you that element, metal, non-metal, metalloid. So what are the example of metal, non-metal, metalloid? You know about this one. I am not going to so much details on this part. Okay, so we can go to the next part, which is known atom and molecule. So already you have an idea that who gives the term atoms. In modern science you have the idea that John Dalton has given the atomic theory, and he has given that atom, okay, the atom terms. Now when you know that the matter is made of teeny particles, and the smallest particle of any matter is known as atom according to the Dalton's. Now if I talk about the hydrogens, you can see this one atom and this one atom of hydrogen, when they mix to each other, and obviously in the when they mix, they are forming a molecule of hydrogen. Similarly oxygen atom mixed and forming that oxygen molecule. So hydrogen molecule, what is the formula of hydrogen molecule? H2. What is the formula of oxygen molecule? O2. So these things are very common, you know very well. Now these two, what I have written here, that 2 and O2, so this is called the atomicity. This is called atomicity. Now the question is that, okay, what is the atomicity? So atomicity is the number of atom present in a molecule is called atomicity. So for hydrogen, oxygen, atomicity is a 2. If I am asking you that, okay, sodium, what is the atomicity of sodium? So remember that atomicity of sodium is a 1. Atomicity of the sodium is a 1 because sodium is a monoatomic molecule. Okay, similarly, if I talk about the helium, neon, that means all the inert gases, all are monoatomic gases. Okay, now suppose monoatomic, we can understand, we get the point that diatomic, that means hydrogen, oxygens are diatomic. If I talk about the nitrogens, so nitrogen we can, so if you talk about the phosphorus, phosphorus is a tetraatomic, or you can say polyatomic. So these are the example of different atomicity. So this part you have to know. Now we are moving to the next part, international systems of unit, or in short we are talking about the SI unit. So obviously whenever we are measuring something, we are quantifying something, so we should have to give a unit so that we can get an idea that how much amount we are asking. Okay, suppose you are going to the market, you are asking for one potato, nobody will asking, okay, they will give a one potato to you, but actually either you have to take that, okay, 1 kg, 1 gram, that 100 gram, like that unit is required. And obviously the in the previous time, two unit generally working, that time that metric systems was there. But on the year of 1875, in the General Assembly, that 17 nations sign up for the to establish the international system of unit, and they just, we can say, they give the 7 base unit, the given base unit, and that is called the SI system unit. And from the base unit you can make any other different unit. So first of all, what we are getting, that what is international system of unit. So the 7 basic unit which has been given there, that length, mass, time, electric current, thermodynamic temperature, amount of substance, luminous intensity. So what are the unit of this? So here it is already given, I am just repeating once again, that when I talk about the length has a meter, mass has a kilogram unit, then time has a second, electric current has a ampere, thermodynamic temperature is a Kelvin, amount of substance is mole, and luminous intensity is candela. The important thing that you have to know the symbol of the unit. So that is a very important. Many of you are writing that this is the meter unit. This is not a meter unit. Meter unit is written like the small m. So this part you have to remember when you are writing kg, that k and g both are in small, not k capital. So these simple things you have to keep in your mind when when you will use the unit. Okay, so here after that we can move to the next part, mass and weight. So generally when we talk in the classroom, or in, you can generally saying that, okay, mass and weight are equal, but actually both are the different terms, both are different terms. When I talk about the mass means the substance, the amount of matter actually present, that is called the mass. What I am telling, that amount of matter that actually present, that is called mass. But when I talk about the weight is the force exerted due to the gravity. Weight exerted due to force exerted due to the gravity. So if I talk about the amount out of mass and weight, which one is the constant? Mass is a constant, but weight is not constant. Weight can be varies because it depends on the gravity. Suppose you are measuring one substance in earth, and you are measuring one same substance in a there is space, then what you will observe, that obviously the huge difference in the weight. So it can be that weight can be zero, because if gravity is zero, then weight will be zero. But mass cannot be zero, because mass is the amount of the matter. Okay, so this part you have to remember, that when you are giving that information, that what exactly we are saying. But remember that whenever in our chemical lab, or in exactly we are measuring the mass, we are not measuring the weight. So that point you have to remember. So two type of balance generally we are using to measure the mass. So one is the analytical balance, this is the old method, and another one is the digital balance. So in our lab also digital balance is there and we are following the digital balance, but you should have the idea of the analytical balance also. So and now I am not talking about the details of analytical balance and digital balance, because that is a part of the practical, and the practical class will elaborate this one. I am just telling about these terms because you are now growing, and obviously these little things you have to keep in your mind. So now we are moving to the next part. Volume. Everyone knows about the volume. Volume. What does mean volume? Volume is the amount of space occupied by substance. What I am telling, suppose I have the glass of water. So the volume is that amount of space occupied by substance. So what is the SI unit of volume? So obviously it is a unit of length cube, and SI unit will be the meter cube. That if I talk about that what is the SI unit of volume, the answer will be the meter cube. But in generally we are using another a common unit which is a not SI unit, that is a liter. It has been there that we are generally using the liter unit. Okay, it is a very common unit that we are using to measure the volume of liquid. So the conversion of the unit is also important. Conversion of unit is also important, and that is why I am giving here that what does it means 1 liter. 1 liter equals to equivalence to 1000 milliliter, and 1000 centimeter equivalence to 1 decimeter cube. And one very important, remember that 1 decimeter cube equals to 1 liter. 1 decimeter cube equals to 1 liter. So this part you have to keep in your mind, that these things are also present. Okay, the unit conversion is a very important thing. Now we are moving to that. Okay, some graduate the volume measuring device is there. Number one is the volume. You can see, take from the, okay, sorry, from the right hand side, that volumetric flux, graduated cylinder, pipette, burette. So these are all the graduated. Okay, so generally we are using these volumetric this volume measuring devices in our practicals lab. In your class 11 these are generally present. When we will go to the lab, obviously these things will talk one by one, we'll see the application also. So now we are moving to the next part, what is density. I don't need to say that what is density, because everyone knows about the what is density. Density is nothing but is a amount of mass present in a per unit of volume. Amount of mass per unit of volume is called the density. So if I am writing the formula where d equals to density equals to mass by volume. So if I am asking you that, okay, what is the SI unit of density, so you can easily say nothing, it is nothing but the kg per meter cube. It is a kg per meter cube. It is also given here, so you have to remember these things. And you know very well that at 4 degree centigrade temperature, water has a maximum density. So these things also is key, you have to keep in your mind. Okay, so we are getting an that important aspect, that density we are getting an idea. So after that, the volume, we get an idea of the mass and object. Then we are talking about the density, so we are getting the idea of the density as well. Now we'll move to the very important topic, that is called temperature. So generally we are using three scale to measure temperature. One is the degree centigrade scale, second one is the Fahrenheit scale, third one is the Kelvin scale. So generally you can see here the three scale we are generally using. But what is the SI unit of temperature? You know that SI unit of temperature is a Kelvin. So it is also mentioned here that Kelvin is the SI unit. And generally from now, if I am telling that you have to also practice to use the Kelvin temperature, because I have, obviously we are seeing that students are working and continuously they are writing degree centigrade, degree Fahrenheit. They are not accustomed to use the Kelvin temperature, and that is why from the beginning I am telling you that you have to learn to use the Kelvin temperature. Okay, now coming back to the point, sir, if it is given sorry, if it is a given temperature in the degree Fahrenheit or in the degree centigrade, how can I convert into the Kelvin scale? So that is the important part, and we have to learn this one. So two important relationship I am talking about. Already you can see that the relationship is there. That what is the relationship between the degree Fahrenheit and centigrade? So this is the relation. Degree Fahrenheit equals to 9 by 5 into degree centigrade plus 32. So this important is that relationship you give you the relationship between the centigrade and Fahrenheit scale. Another formula is there which shows the relationship between the Celsius and Kelvin scale. That Kelvin equals to degree centigrade plus 273.15. Now I am just telling that obviously the value 273.15 has been given here, but you can use the degree centigrade plus 273, that round up value you can use, that round up value you can use to measure the temperature in Kelvin. Generally we are doing this one. Suppose here it's very good important thing has been given, that our normal human body temperature is 36 degrees centigrade, actually 36.8, but we are taking the 37 degrees centigrade. Okay, so what would be the temperature in Fahrenheit scale? Obviously they have measured already, but from the equation also you can get the value, that 98.6 degree Fahrenheit. And if I talk about that, okay, that temperature, what is the in Kelvin temperature? So you just add this temperature with the 273, you will get that 298, that 310 Kelvin. And one common things you have to remember, that way in the obviously in the chemistry, when you talk about the room temperature, so which value we are generally taking as a room temperature? 25 degrees centigrade. Now you cannot say, the very important point nowadays the summer is there, you cannot say okay sir, room temperature 25 degrees centigrade, it is not possible. But okay, but we generally we are taking 25 degrees centigrade as the room temperature, which is equivalent to 298 Kelvin temperature in the Kelvin scale, and equivalent to the 77 degree Fahrenheit in Fahrenheit scale. So if I am asking you that okay, 25 degrees centigrade equivalent to 77 degree Fahrenheit and 298 Kelvin. So up to this we are giving the that up to temperature today we will discuss. Again we will continue that next topic in the from the next class. So I am concluding my video here. Again we'll meet, till then goodbye, take care, Jai Hind.